Julian, let me know when you're ready. Okay, you can go. Alright, so today we're going to talk about, you're probably hearing everyone else's conversations, but we're going to go a little deeper. You're going to be talking about factors, products, and prime numbers. So we're going to kind of skip over the factors and the products. We're still going to talk about understanding them. We're still going to write the F's and P's underneath like other groups were. We're going to focus more on prime numbers. So, first thing I want you to do is in your notebook, I want you to write down what you think a factor is, what you think a product is, and what you think a prime number is. Give me an example of each of them. I'll give you 3 minutes to write that.
Mr. Mars doesn't say. None of us have the name.
Yeah, mine did before, but now it doesn't.
What? Fill in your name on the scores card.
You showing 6 is
Doesn't
It
have.
did for mine before. Mr. Mars, the code's not working.
I know.
The code doesn't work.
Wait, that?
If you have questions, ask someone who's already done it. I'm getting the...
I just typed it. It's not showing anything. I'm losing time. It's not showing. No.
Did you do it in all caps?
I know he's doing the article, reload it. Now, hopefully it shows up. Yep. Yeah. That'll be on the how-to tab. Wait, for how much would you pay? Oh yes, yeah, that is. It's in the... Okay. And then you go to sign in. At the bottom on the right, the left side, it says sign in, and then you sign in with a Google account. Alright, someone in this group tell me what factor is. Yes?
A number, multiplication sentence. Oh.
You click on the link, but don't
That
exit out
equals
this,
product.
so you can fill it out at the same time.
Okay. Does everyone agree? Does that make sense to everyone?
But don't exit out that because that's
No. Okay, so what's a multiplication sentence? Someone give me an example of a multiplication sentence. Yeah.
I'm doing easy.
Equals, question mark.
um,
Okay. So, looking at this number sentence, okay, number sentence and equation, same idea. Multiplication means it's going to be a multiplication sentence. Which numbers are factors? Yeah, so I'm going to put an F underneath those. And for the next 3 days, just this rotation, I want you to put F's and P's so that you remember where factors are and where products are. Because sometimes you might write this the opposite way. So you might write blank equals 23 times 5. So that means that the factors are actually on the other side of the equation. Okay, so just for the next couple of days, I want you to do F's and P's. After that, I'm going to assume that you understand them. Okay? So in the numbers in multiplication sentence that equal a product, so these are the numbers, that makes this the product. So I'm going to put a P under there. Someone tell me what a product is. Hey. Answer to multiplication problem. Looking at factors and products, are they specific to multiplication? I know both of you said, okay. What's that? If it's prime, it can't be a product. Well, yes and no. Because a prime number, and we'll get there in just, actually let's just, perfect segue. What's a prime number? Keely's, you can do it. Number with no multiples, or is there one set of multiples? So number,
Anything. It's one, and it's unsolved.
call it y, so it's a variable. So a number that 1 and y are the only factors? Okay. Okay, so looking at that, can a prime number be a product?
No.
So let's say I'm using the number 7. 7. So 7 times 1 equals,
No.
is this a prime number? Is it a product?
Oh, besides this one.
Right. So that's correct. That's an awesome way to explain prime by using this example here. But the product, I wouldn't include anything about prime numbers because prime and product aren't really related. Okay? But that was an awesome segment. So in this problem, where am I going to write my S and my P's? Okay. Okay. Very, very good. Alright, so what are some other examples of prime numbers that you can give me? We talked about 7, I just gave you that one. What's another 1 or 2 of them? 5 and 11. 2 is definitely 1. Let's do one more. 8. Okay, 19. So now that we're talking about prime numbers, and I see you, Keely, but we're going to move on. Now that we're talking about prime numbers, there are a couple tricks that are going to help you with large numbers, because right now you're pretty good at the 1 to 20, 1 to 30 somewhere. I know you are because we did the exercise with you. So, there are a couple different ways that we can make prime numbers really easy for big numbers. The first one is telling if it's an even number, because even number means it's always divisible by 2, okay? Except for 2, because that would be 2 in itself would be 1, right? Okay, so the first trick is if it's an even number. Okay, these are some things you can write down that might help you. The second trick, so I'm going to say x divided by 2. X is any number, and it can be divisible by 2 if it's even. Okay? Question? Odd numbers can be prime numbers. Even numbers, unless they're the number 2, can't be prime. Okay? Because 2 is prime, the rest of them are not. Okay? So the next trick to be able to tell is with big numbers, to see if things are divisible by 3, all you have to do is add the digits together. So I'm going to throw out a number 711.
Oh my goodness.
Looking at it right now, do you know if it's prime? No. You might, but actually you know if it's not prime. But what you do with these 3 numbers, and you can do this with a number that's 20 numbers long, or 3 numbers, or 2 numbers, you're going to add the digits together. So you're going to go 7 plus 1 plus 1 equals 9.
It's divisible by 3.
Is 9 divisible by 3? Yes. So therefore, this number is divisible by 3. Therefore, is it prime?
Yes.
If it is divisible by 3, it's not prime. Okay? So let's just someone just give me a big number, like in the thousands.
1,074.
1,074 would be prime, or would be even.
1,073.
1,073. Okay, so let's add all these together. So 1 plus 0 plus 7 plus 3 equals 11. So does that make it prime or not prime? Prime or not prime? We make it prime.
It's still
Okay.
there's still a chance.
There's still a chance in other ways, and you might have to look at it more deeply, but you know it's not divisible by 2. You know it's not divisible by 3. The third trick, and this is more, you have to look at these first 2.
That's 4.
Oop, sorry. The third trick is for 4. If it's divisible by 4, it has to be divisible by 2 and 3.
Yes.
So if you look at these 2 tricks and they both work, that means it's divisible by 4. What's another number that you think could be divisible by, based on the fact that it's divisible by 2 and 3?
Dude,
It would always be 6. If it's divisible by 2 and 3.
dude, it's
Because 2 and 3 would be factors, which means they can be multiplied together. Okay? So the first 2 that I would look at to find out if the number's prime are going to be the 2, I'm just going to say 2,
and it's
and 3. Because if 2 and 3 work, then you've got 4, you've got 6. The last trick, and this time it's actually 4. The last trick is going to be, what does a number have to be divisible by 5? It's
It has to have end in 0 or
0 or 5. Okay? So a number like this doesn't end in 0 or 5. It doesn't add up to a number that is divisible by 3, and it's not even. So right now, looking at it, I'm going to guess it. Okay, does everyone understand that? And it pretty much goes up from there. Because if you have 2 and 4, then it's divisible by 8. 7 is a tough one. 7 is a prime number. Okay? So do you have a general understanding of prime numbers? Okay. Then the next thing I want us to do is, in your notebook, I want you to do 3 problems. We're just going to do 3. We're going to keep it nice and short for you. The first one, I'm actually going to cut down the first
My
problem.
name is Red.
First problem is list, let's go list 4 prime numbers that are greater than 100. Okay, so 4 prime numbers greater than 100. The second problem, yes, no, 4 new ones. So try to keep it between like 100 and 200. The second question, and actually I'm going to read these to you so you don't worry about writing these 4 prime numbers down yet. I'm going to read the questions to you. The second question is each child has 50 pieces of candy. If there are 6 children, how many candies are there in total? So there are 50 pieces of candy per kid. There are 6 kids. How many total? And the last question is Nancy has 9 boxes of bottle caps. Each box holds 50 bottle caps. How many bottle caps does Nancy have? So those, if you can't see them or don't remember them, you can walk up and take a look at that really quickly. I'm going to give you about 2 minutes to do that. And then we'll have people come up and write this. No. Ladies and gentlemen in the classroom, you've got about 4 more minutes in this station. Did you watch the video? Okay. It's the same, okay, with iPad go to, you're going to go to desktop version, and then it will show like this. So do you have upper amount? This is where it gets tricky because iPads are way better. Switch it to desktop version, then it will show up just like it does on desktop. Okay. Alright, well, you still need a couple more of the. Oh yeah, you're good. Nope, not yet. Alright, 4 prime numbers. Someone read some off. Give me 1. Keely, it's gonna be 1 prime number over 100. 101. Okay, is divisible by 2? Yes or no? Is divisible by 3? Which means it's not 4. Is it divisible by 5? Which means it's divisible by 6. Okay, so right now, prime. Good. Erica, another.
Yeah.
122. Let's look at that one. Is it divisible by 2?
Yes.
Yes. So we know that one's not prime. Let's give it another shot. Bridget? Did you? Oh, you're both. One and then the other. Doesn't matter who's first. Go ahead.
Neither one.
213 is divisible by 2. Is it divisible by 3? 3 plus 3 is 6, which means it's divisible by 2. Okay. Other Bridget? 179 is divisible by 2. Is divisible by 3. 9 plus 7 plus 1 is.
You don't have 1,000.
This is 16, 17. Yep. So is it divisible by 3? Divisible by 4? If it's not 2 or 3, it can't be 4. What about 5?
Ha.
Okay, so would we say it was prime? Alright, give me another example. 8. Let's do one more bit move on to the next one. Give it an example. 173. Divisible by 2?
The heck?
Divisible by 3? Okay, so that's 11. So is it divisible by 4? Divisible by 5? Alright, we should be good to go.